And good morning, everybody. We are live. Congratulations. You made it through the week. Another week of fantastic food safety, food quality, amazing products. And if nobody out there says this, because a lot of what we do in food safety goes unheralded, Kai and I are going to say it here today. Good job. You did a good job. We really appreciate all that you do. If you're new to the Food Safety Chat, welcome. Pull up a chair. My name is Bryan Armentrout with the Food Leadership Group. And every week at this time, 8 a.m. Mountain Time, 10 a.m. Eastern on LinkedIn, YouTube, and Twitter, we do a live stream, and I bring an expert in food safety onto the chat, and we have a conversation. And it's always fantastic, and we always have the best people on. And what you'll notice with this, not a presentation, not a lecture, we're here to help inform and educate. And so the interaction is the best part of what we do here today. So as we're talking, throw your comments in here on the chat and let us know, and we'll weave it into the conversation as we're going around. And one of the things here on the chat that we love to do is let us know where in the world you are at. And I am in Loveland, Colorado, where it's going to be hitting 100 degrees here today. So plenty hot. Kai, where are you at in the world?
Just outside of Fort Worth, Texas, and we're going to hit 100 degrees as well today.
At least here in Colorado, we don't have the humidity you guys get, so that's at least a little bit better. So today we have a new guest on. I always love it when we have new guests on. So I have Kai Luker, who is with FlexRay, and really happy. Welcome. Glad to have you here, Kai.
Thanks for having me. Excited to be here.
So one of the things that we love to do here on the chat is get a little bit of background. So why don't you kind of tell everybody a little bit about who you are and what you kind of do?
Yeah, I'm born and raised in Texas and grew up on a dairy farm and tried to run away from that as fast as I could when I went to college. But unfortunately, I studied food science and never could quite escape. Stayed around the dairy industry for the most part of my 15-year food career, and then spent the last 8 years with FlexRay in various roles and operations, and I'm now the chief product officer at FlexRay. But have a serious passion for food safety, from the farm level to the table level and everything in between, all the hard work that goes into it, and excited to share a little bit about that experience.
Nice. So what do you love about working in food safety, Kai?
I think it's very similar to literally just preparing a meal for my family in the kitchen, just the care and the concern and what goes into, making something that someone is going to consume, whether that's just from a nutritional aspect or get them through their day. I think it's just on the much broader, grander scale whenever we're making food from a manufacturing perspective, and to have the proper care for safety that goes into that, whether I'm making a single meal or I'm making 10,000 pound batches of something. I think it's the same mentality.
Absolutely. Yeah, that's the absolute right attitude for that. Hey, Duncan, thanks for joining us here today. Good to see you. We're making this food for people, and sometimes when we're working, we forget that. It's if you're working in a big food plant, you see the product going out the door day in and day out, and you lose touch of that. So it's always good to kind of circle back on that and remember everything that we're doing. So that's a really good point. Thanks for bringing that up. So one of the things that we love to do here on the chat, Kai, is everybody joins us for a ceremonial drink, just like Tim, I'm sure, is raising his mug as well. So cheers, everyone. Very good. Was that a Texas Tech mug I saw there? Is that what that was?
Yeah, I'm not a Texas Tech alum, but I spent a lot of money putting my daughter through undergraduate there. She finished up in December and is about to start her master's at Texas A&M in the fall.
Well, yeah, that's right. The least you should get is at least a freaking mug.
That's right.
Yeah, it needs to say on there something like, my daughter went to Tech and all I got was this lousy mug or something like. Remember those T-shirts we used to have? Got a dad joke here for you. Everybody brace. Here comes today's dad joke. Kai, what did the janitor say when he jumped out of the closet?
Not sure.
Supplies.
That's going to get used later. My son's going to hear it.
I love it too. So one of the things year in, and year out, Kai, we talk about this here on the chat quite a bit. There's always kind of the top three areas for recalls, and that's microbiological, salmonella and listeria are always up there. Allergens is always there, and it generally gets back to oops, mislabeled that. And the third, every single time, is foreign material. And I pulled up yesterday, the 2023 data, which is the most current for FDA. And it's way up there on the list, of course. So it seems like it's kind of one of those things that we just kind of roll our eyes and say, oh, geez, we have another foreign material problem. Let's try and find it. And we just kind of roll on to the next thing. But really, I mean, why can't we get these things down? I think part of this really, and today's going to be kind of more of a technical conversation, which is kind of cool. I love these. Is why in your opinion, Kai, is foreign material such a darn hard thing for food plants to get a hold of?
Yeah, I wish I had a singular answer, but there really is not a one size fits all. There's, from a food industry and manufacturing perspective, how far we've come in the last 30 years is tremendous. And, the improvements year in and year out, the way that we're able to, manage holds and manage production is significant. But the speed of manufacturing, and as much as a lot of the general public might like to think that, everybody in the food industry is making tons of money, the margins on a per unit basis really aren't that large. And, how we have to manufacture and produce and get everything through the supply chain, things happen, things break down on a daily basis just due to the way that we manufacture food products. And, every day everybody's trying to juggle and maintain that as best they can.
Mm-hmm. No, that's a good point. I think part of it too is that the technology is improving. The good analogy here as well is chemistry. We used to, it was cutting edge when you would measure things in parts per million, and now it's parts per billion. And we're seeing things that we didn't necessarily see before. Was the contamination there before? Yeah, probably, right? The arsenic was in there at a low level. You just couldn't detect it. It was below the limit of quantification. And now we can, and we have kind of a quandary. It's like, oh, we have, 2 parts per billion of organic arsenic. What do we do? Is it a risk or not? And definitely, I think we see that in the foreign material space as well. So we're going to be going over some really cool stuff around that today. But I think another big piece of this as well is the technology itself, Kyle. And that's why I'm so glad that we get the chance to talk with you here today. Is I know from a quality standard, the things I learned about how metal detectors work, and then later on X-rays and things like this was just pretty much self-taught. I would go out and learn and say, okay, well, what makes for a good metal detector? And a lot of times this was just forced behavior, because you would be in a plant meeting and the plant manager would say, oh, we're putting in a new line and we need to spec it out. And the metal detector was part of that. And you're like, okay, what do I need to understand? And you start working with the maintenance guys and the engineering guys to figure it out, because a lot of times it's just, oh, hey, I got these three little wands that I run through every hour, and that's about all I know. So is that kind of your experience too with people you work with in the food safety space?
Absolutely. I could tell you down to the level of detail that would bore most people to death how a swept surface heat exchanger is supposed to work, and have worked on them, in and around them for much of my career. You're taught that from a schooling standpoint in various classes, but we don't take a deep dive into detection technology very often, and we have to become experts out of necessity instead of just the practical use of it. And unfortunately, that leads to us trailing a little bit, or having to rely on outside influences in order to pick the best detection equipment.
Yeah, and a lot of times it just comes down to, it's like, operations people come into your office and it's, hey, Bryan, we had the metal detector go off and we think we got some stuff in product, or we're missing a bolt. We need to locate that. Whole bunch of product gets on hold. And then it's like, oh, we had a quality problem. Why did this happen? Which just irritates me to no end. Really around this is, you need to get some understanding on how these different technologies work, because what we'll get in here today is they'll have pros and cons. Some things are extremely expensive, and it doesn't necessarily mean it works better. There's all kinds of different factors you need to take into account. We'll kind of dive into those here today. And really, with foreign material detection, one of the things that people don't understand around this is it doesn't replace good prerequisite programs. Just like anything else, you have to have the blocking and tackling in place to have a good program around foreign material. So the whole objective of what you need to have in your facility for the control of foreign material is the upfront work. What are you doing on your preventive maintenance programs to make sure that the Teflon scrapers in the bowls are replaced on a regular basis, that all of the pieces for the machinery is there before you start running? What do you do if you have something detected? Are you buying the bottom of the barrel, cheapest gaskets that you can find? Are you buying actual high quality gaskets that aren't going to break down after a week and end up in your product? These type of things all come into play. Your foreign material detection programs are the kind of the last link in that chain of, if everything else doesn't work right, you hope that that's going to succeed and find what the other things weren't able to find. But you can't rely on it as your, I've got a metal detector, everything's fine.
Absolutely, 100%. It's just, the safety net for the trapeze artist. We want to be able to do all the rest of the exchange as well up front and execute those continuous improvements and preventive maintenance aspects of our food safety programs to perfection whenever possible, or as close to perfection as possible, and hope that we don't have to rely on detection mechanisms later. But we do want to have the best detection mechanisms possible, because the other side of that same coin is we can't fix things we don't know about.
Exactly. Well, and part of this too, and implicit in what I was talking about here, and this is something that I think a lot of times food safety people forget about, is your metal detector is not going to pick up glass. Your metal detector is not going to pick up plastic or gaskets or other things in that same category. Your metal detector may pick up some metal. Guess what? Stainless steel, not very good at being picked up. That's why those different, little samples that they give you on those wands to run through are different sizes, because that's the sensitivity of that machinery associated with that particular setup, and it's all different. But if you have, issues with those, they're gonna go right through. And for that top 3 for foreign material, Kai, you see in there just as often as metal is gasket, hard plastics, and other things beyond the metal. So again, on that side, and I wanted to make sure everybody is kind of drilling this into your head, is that metal is only one contaminant that you need to be looking at in your product. There's a whole myriad of things out there depending upon your particular product matrix that you need to be identifying in your food safety plan.
Absolutely.
So looking at the comments here, good comments here today, guys. Tim brings up a good thing here that I want to at least emphasize, is that surrounding yourself with experts you trust is critical, and that's part of what we are indirectly emphasizing here on the chat. Is I don't have to know everything about metal detection. I need to know enough to have a conversation, but I need experts in my roster that I can call up at any time when I do have a problem. So, like you had said earlier, Kai, right? You know more about this subject than I'll probably ever learn in my lifetime. But if I have a foreign material problem, I can pick up the phone and talk with you about that and get a better understanding of it. It's kind of like having a good mechanic for your car. You don't have to know everything the mechanic knows, but you have to know at least enough to put that mechanic in the right direction when you have a problem with your car.
Absolutely.
So Duncan here, this is kind of common procedure here, isn't it? I've seen manufacturers take product that have been subject to a contamination incident and retest it through the metal detector 2 or 3 times and then declare it safe. In some cases, people will pervert foreign body detection equipment in the name of product release. Absolutely.
Yeah.
I don't care how many negatives you have, it does not negate a positive. And a lot of times people think that's the case. Oh, we had a micro hit. Go ahead and retest it. And you retest and it's negative. Okay.
Yeah.
So what? You still had a positive. And it's the same here. You need to have good processes in place. I was in a plant one time where I was touring around and we were looking at the metal detector, and I would see, product going through, and they would run the wands through, and the wands weren't being detected. And I was like, whoa. So I went up there and started talking with the operator, and the operator after a little bit said, yeah, this metal detector goes off way too often, so we changed the settings.
Yeah, I wish I had never heard that before, but unfortunately, I've heard the same.
And another good one is you have your detection system and you have a kickoff mechanism to take that product off the line and put it in a basket or things like this. I've had instances where the metal detector did its job. The arm swept the product off the line into a little bin that's on the side of the conveyor belt, but there was no way that you could isolate that. And we had a shift change. And so the new operator came in, saw some product in that rejection bin and said, "Oh, wonder what this is doing here." Put it back on the line. And we figured that out because we had a complaint from a customer who found something in the product. The metal detector did a great job, but the people involved with the process weren't managing it correctly.
Yeah, to Duncan's point, an inline piece of equipment can be an effective tool for reinspection, but oftentimes we lack the expertise in-house to slow that down and improve the detectability. We're still just reinspecting it at the same production speeds and same sensitivity levels that we did the first time around, and we're missing an opportunity.
Absolutely. So what we wanted to kind of do here for everybody is kind of do a quick, what we kind of called here, foreign material detection 101, and getting kind of that baseline understanding of the different technologies, what's some of the cool new stuff that's coming out there, and kind of run through that information. Does that sound good, Kai?
Absolutely.
Cool. So let's pull up here our handy dandy summary thing. So here we go. So obviously, guys, we're not going to read this to everybody. And in the locals group, or not the locals group, but on the Food Safety Chat database, I'll put this presentation in there along with this recording so that you can have this for your own information as well, if that's okay with you, Kai.
For sure.
Awesome.
Nothing proprietary in here.
And sharing information is what we're about here. So here's the different basic types here. Can you run these through for us, please?
Yeah, absolutely. I'll skip metal detection and X-ray for the most part. I think that everybody has at least a good feel for those two things. We can talk a little bit deeper about X-ray later, especially as it relates to CT technology, as where X-ray is going. Vision systems. I can remember the first vision system in an organization that I worked for in the early 2000s. We were putting in vision systems for recognition of packaging materials to ensure that we were putting the right SKU and the right packaging materials together. Those vision systems have improved so much, and hyperspectral imaging is now another layer on top of those vision systems, where if you're able to inspect on an open conveyor belt product, whether that's fruit or vegetable sorting or parts and pieces, hyperspectral is significantly a good way to help detect foreign objects. And it can be part of a good qualitative analysis as well, because of the way that the NIR aspect about hyperspectral imaging. We'll go into hyperspectral a little bit further in a moment. So that's just kind of the 50,000 view of that. And then microwave. I think microwave is one of the neatest technologies that's out there for foreign material inspection. Unfortunately, it is also the most limited. So like a metal detector, there's a metal detector has a constant signal, and we're disrupting that with the product or foreign material. In microwave, your product has a signature as product passes through the microwave portion of the piping system. And when that signature changes, there's something else that happened. Now, that can be nutritional in nature, but it's very effective at foreign material detection, even with things like gloves and bag liners, where almost everything else it's impossible to detect with. But again, it is the most limited use case as well, unfortunately. And then CT technology, I'm spending a lot of time personally right now diving into CT technology, as that's going to be the kind of the next generation of X-ray expansion in the food industry. And it's essentially X-ray, but on a 3D level. So a lot of the things like the location of wire or a foreign object within the product matrix, CT helps overcome those things, and it puts that into the right imaging location at any time.
Interesting. Yeah. So what does CT stand for?
Computed or commuted topography.
Oh, interesting. So it's essentially mapping it. Is that what it's saying?
Yes.
Huh, cool. Lisa asked for a little follow up here. So Cortland had made we'll tackle this right away. Cortland had made this comment. FDA out of spec procedure. No negative can be dismissed. Kind of what we were talking about here a little bit. And Lisa had a follow up and said, "Hey, can you give me a little more information on what Cortland was just talking about here?" So, as an example, when you're talking about positive results for micro or even contaminants in the chemistry side, let's say arsenic, like we were talking about earlier. Let's say that you have an environmental monitoring program and you go out and you pull 20 samples and you have one that's a hit for listeria on the floor. Then you go out and you do your vector analysis and you look at it. You can't ignore that first positive result. It's like, oh, I have something that I need to follow up on. You just couldn't go back and resample the following month and they're all negative and say, oh, okay, that's cool. It just evidently went away. No, FDA is going to have a major problem with that because you had a hit. What did you do about that hit? Did you redo the vector analysis? Did you do recleaning? Did you do different procedures? What did you do to close that defective action? I think Lisa, probably the biggest textbook case of this was Peanut Corporation of America. So as we'll brief background on that. So peanut butter manufacturer, and they were producing product that was contaminated with salmonella. And the owner of the company, Parnell, saw these positive results and told the quality manager to retest. And she did retest, and the results came back negative, and they released the product. And this happened several times. And people got sick. People died because of that. They were under this false assumption that those negatives would somehow negate that positive, and that is absolutely not true. They had a massive recall because of that. Parnell's still in jail. The quality manager went to jail as well because she knew it was wrong, and she went along with what the CEO said. So just say, oh, I was following orders. That's what my boss told me to do. No. And so it's very important that you teach senior management that you can't negate those positives. They don't go away. And it's the same with what we're talking about here in foreign material. If you have a hit, you need to investigate and find out where it came from, why it happened, segregate it, and disposition appropriately. Does that make sense, Kai?
Yeah, absolutely. I'll take it to the foreign material space, if I may. It would be like having an incident. Your metal detector signaled something. You kicked off and you detected and found some metal shavings. You went upstream and you looked and you made a bracket. You put that on hold, and you re-inspected everything. And you had more kickoffs during the re-inspection and decided that you effectively scrubbed the product clean via re-inspection. Mm-hmm. Well, that should not be our approach. If we bracketed, X amount of product, and now we found where the pocket of kickoffs are, then maybe we, reassess that portion of the hold, and we might release, where there were no hits, those types of things. And so using, that first presumptive, that should not mean that hey, we can inspect our way out of this. We can reduce the hold on the foreign material aspect, but we can't scrub the product clean.
No. And the classic example for this for me is the good old gasket, right? So you've got that rubber gasket. It's sitting on your desk in the morning. About 3/4 of the gasket's there. There's 1/4 of it missing. Where did it go? Okay. And so when you're looking at your plant design, it's always a good idea to have screens and filters in secondary systems. So sanitation, CIP returns, filter, so that you can potentially catch those pieces of that gasket, because part of your foreign material investigation is going to be recreating that gasket and finding all of those parts. You can't say, it probably went down the drain. Yeah, sure. until a consumer finds it in the product and they take a picture of it, and now it's all over social media, and you're like, oh, hey, there's that missing piece of gasket I was looking for. Nobody wants that. Quick reference here that Cortland. We've done whole shows on the Park Doctrine, but so that just everybody is on the same page. The Park Doctrine, in a nutshell, is if you're the head of the company, you cannot delegate food safety. It is your responsibility, and you can't say, "Oh, that's the food safety guy's job. I expected him to take care of that, and I can't help it if he didn't do that." Park Doctrine is nope. Under the law, and this was a Supreme Court ruling in the 70s that established this precedent. you cannot delegate that authority. And as the head of the company, you can be tried criminally. And from a libel standpoint, well, not necessarily a libel standpoint, but criminal. I forget the other legal term associated with that. But you're on the hook. You're on the hook for that type of activity. So that's a very short explanation for that. So the first three types, I think most people in the food industry are, at least familiar with these. And if you've ever seen a vision system working at a peanut operation where they're sorting peanuts, holy moly, right? Those machines are going and kicking stuff off. It's crazy. So let's dive in here with the deck. So how does metal detection work, Kai?
So I'll just treat this like a refresher for the most part. The metal detector is creating a signal, and the metal is disrupting either the conductivity, the electrical aspect of the signal, or the magnetic aspect of the signal. And then the food itself can interfere with the ability for us to produce a good signal strength. So the less the product interferes with the signal, the more foreign material that we can detect. So high moisture, high salt, high sugar, then we're reducing the effectiveness of the detection from that standpoint. The thing I love the most about a metal detector, it's the best thing for aluminum. It's the most limiting factor from an X-ray perspective in the metal world, that aluminum doesn't attenuate an X-ray very well. But because of the conductive properties of aluminum, it's fantastic. So oftentimes people are replacing metal detector for X-ray. I'm a bigger proponent of finding a way to use both, especially if aluminum is a potential failure mode in your manufacturing process.
Interesting. Yeah, I didn't know that. I mean, so part of this too, there's always been a few factors that I've heard relative to these type of devices is, as you had mentioned, product size. So it's going to be a lot easier to, find a piece of metal in a little thing like this versus a 50-pound bag of non-fat dry milk, because you just have that much more product to look through. And then that also impacts, I guess, what's this, the aperture size, right, Kai? So the size of the opening that the product is going through. And as I've heard, and, whack me down if any of the stuff that I'm saying is incorrect, is the bigger the aperture size, the less sensitive it is. So you're going to be able to find less stuff. The belt speed is going to have a huge impact. As you had said before, the product matrix, what is actually going through that product. What about product that is wrapped in different types of foils? And we've seen this too, right? Where you have a product that's got an aluminum seal on the top of that, and you had said, "Wow, it's really great at picking those up." So if you've got that, pretty much, metal detection's out, right?
Virtually. There are very few applications where a metal detector is going to work in any type of metallized packaging.
So that's pretty good. So that was really interesting. I didn't know that sugar is a problem for metal or for X-ray, or not X-ray, metal detector. Sorry. So why does sugar interfere with metal detection?
It's similar to salt, has conductive properties.
Oh, so it's anything that's So do products in that have a high moisture content? Is that a problem
Correct.
for metal detection? Okay. Interesting. I didn't know that. Very cool. So let's take a look at here at the next slide. So X-ray. So how does X-ray work? We kind of have a general idea, but I think it's different for food. That's for sure.
Yeah, I try to approach this from the typical inline instrument. Almost everybody is using a diode as the detector, and then a fan beam on the X-ray source. And it's essentially, we're indexing product across the diode. And so it's making a decision based on the slice. Whenever we see the image on the screen, it's just rebuilding the composites of all the slice from what it indexed through there whenever it rejected it. And the best thing that we can do as it relates to an X-ray from an inline perspective is ensure that we're using the right detector and the right X-ray as it relates to the product. And sometimes I feel like manufacturers are just selling a user on what the best imaging device is. But Duncan mentioned signal to noise. As it relates to X-ray, we really do get into a lot of issues with signal to noise ratio interference here. And sometimes the best detector doesn't mean it's the best tool for the job, because we need to make sure that we're monitoring signal to noise ratio when we're inspecting products. And some things are easier to inspect than others. Some foreign material types are easy to inspect than others. So not a one size fits all. A metal detector can be kind of a one size fits all approach. The signal is the signal. We're just adjusting the sensitivity to that signal disruption. An X-ray, really, we do need to build out the right set of components for the targets and the application.
So you'd said something here that I didn't know, which is cool. Is you said slices. So the X-ray beam is like pulsing and then taking different.
X-rays continuously moving through the product. As the product moves across the diode is continually taking the signal as product moves across, and it's typically half a millimeter to a millimeter across the diode, and it's making a determination via the algorithm of what it saw.
Oh, okay, I see.
Loosely, as product went across the diode.
So the beam is continuous, but the diode, which I guess is what that little green dude underneath there in this picture is as the food is going across, then that's where the actual measurement is taking place. Got it. So then it's putting together a complete picture of the product, or is it evaluating each of those individual readings as it goes across?
Generally speaking, we're using a photo eye to index product in and out of the X-ray, and so it's building a composite of those slices to represent the whole product.
Interesting. And then it has learning capabilities, as we were talking about here as well, to kind of identify different types of defects within products. Can X-ray machines do that?
They can. Unfortunately for us in the food industry, allowing our data to leave the plant is a bit of an issue. So there are opportunities for us to better leverage machine learning and AI in order to improve the detection and rejection on an X-ray. But for the most part, everything is built from a static or standard algorithm. When we don't improve those over time because we're not feeding that data back to a machine learning system. As we get better about data management and sending that data back out of the cloud from a food production standpoint, there are opportunities to continue to improve X-ray technology. But right now, the food industry, I'm painting with the broad brush here, we tend to hold tight all of our data and keep everything in-house, rightfully so, at the moment.
So to reflect that back, so if I'm hearing that correctly, if I'm an X-ray detection equipment manufacturer, I need all kinds of data from all kinds of different product categories to improve my product, and that's really not overall happening because of concerns with whatever confidentiality or what have you within a company. Interesting. Now, part of what took place in the food industry a number of years ago is some retailers came forward and said, hey, we think X-ray is far superior to metal detection, and we're going to mandate in most cases that you install X-ray equipment if we're going to buy from you. Like, never seemed quite right to me. What's your take on that? I mean, is that true?
I think that at a very high level, it does help to push the industry forward to have, folks like that, create momentum around improved detection technologies. But unfortunately, at the same time, an X-ray in and of itself doesn't mean that we're creating a better detection schema. There are so many components and aspects about creating the right tool for the job that need to be considered in. And in reality, X-ray is not the best for every use case. A metal detector still is the best for certain things.
Yeah, well, I know from personal experience, I had a client I worked with a number of years ago that installed X-ray into their plant for this exact reason that we're talking about. And they were manufacturing fluid milk. So a very standard homogeneous product in half-gallon, gallon, blow-molded containers, what we're all used to buying in the grocery stores. And oh my God, did they fight with those X-ray machines? They could not get those things to work properly, which always kind of baffled me because you would think that because you have it's just milk, right? It should do a great job of detecting through that, but it couldn't. Any thoughts around why? I never got an answer to that.
In that particular use case, no, I would be stumped a little bit as well, but I would assume that it's probably anomalies as it relates to the packaging material. If it's PET bottles and jugs, things like that, various thicknesses in the blow molding process and stuff like that would just excessively signal the X-ray that there's something there when it really is nothing more than a packaging defect or packaging anomaly.
Yeah, it was a major headache for this plant because this was one of their critical control points in their process was this. So anytime this happened, they had to put all the product on hold. They had to bracket around that and do an investigation, and they never found anything. It was just a major nightmare. So I think kind of the lesson around this too is be careful of your design because you think you're doing the right thing, but it's just going to end up making your life miserable.
Correct.
Yep. So as Duncan is saying here as well, is for most products, if you need X-ray, it means something's gone horribly wrong with your prerequisites. So I think this is a really good point that Duncan's making here, and it was something that I said earlier as well. Is don't rely. This is the point of this is not to be your screening. This is just your verification. These technologies are being used to verify that your systems are working correctly. So never rely on them as the actual technology that's going to be preventing the issue, because you're going to be in for probably a bad surprise at some point.
Absolutely.
Let's see here. So what we got here going on in the slide?
So just an explanation of FlexRay inspection technology, the way that we work. So for those of you guys that don't know FlexRay, we're a third-party inspection service. So the food's already been produced. You've bracketed product because of an incident, and we're taking a different type of X-ray technology, inspecting that again, in order to find the things that were missed due to production speeds. In fact, we're inspecting product at a rate of 3 to 5 feet per minute. If you can imagine something being inspected that's that slow. But we're using a flat panel detector, which is the same thing that's used in a heart cath lab for an angiogram. So we're creating a significant, the amount of grayscale, the amount of analysis that we're trying to do, edge separation, contrast, all of those things, signal to noise, some other terms that have been referenced here. It's a lot different, and as it relates to our technology, our X-ray power is higher, our focal spot's lower, those types of things. I'll try to stay out of the weeds too much here, but the short version is an inline instrument essentially is looking at individual slices and the algorithm is making a determination of that. And due to the speed of manufacturing, we are self-limiting the capability of X-ray technology of our own doing. Inline X-ray technology is significantly better at detecting things than the way that we use it most often. But we're not going to make money in the industry by cutting our production speeds in half just to improve detection from an X-ray standpoint. So that's where we come into play. We more than cut those speeds in half and get every ounce of detection capability that we can out of an X-ray and imaging creation in order to find those things.
Well, that's a really good point, Kai. I want to make sure that everybody caught that. Is everything that we do in manufacturing is a trade-off. You could produce a absolutely perfect product that has no defects, no flaws. It's just absolutely beautiful, and it costs $5,000. Nobody's going to buy it. So you have to operate within these frameworks. And one of the things in operations that you always have is you always have a bottleneck in your process. It's just a matter of where is it. And if you put in something that's more efficient, the bottleneck just moves somewhere else. So that's an important thing to pull out of our talk here today, is that these technologies are operating under parameters of operations. You need to understand that they're going to be able to do some things, but they're going to be limited due to the efficiencies that need to be required. So essentially, this is like a low resolution camera, right? It's an iPhone 4, and you've got an iPhone 15 where you can take a really high resolution picture, but to do that, you have to take them a lot more time, which the plants don't have.
Right.
So a lot of times in the past, what I would have happen when I would have a foreign material issue. So I bracket the product, and generally what we would do is like, okay, I've got 10,000 pounds of product on hold. The plant isn't running this weekend. I'll bring in a crew and we'll rerun all that product back through the metal detector to make sure it's okay. But going back to what you just said, that's not necessarily going to help, because all of those parameters for operational efficiency are still in play. So it's still going to be running at that same speed. You're not going to improve your resolution. You may or may not find additional things. It's probably not going to be that helpful, is it?
Correct. Unfortunately, no.
Interesting. That's a good takeaway there. So you think you're doing better, but you're really not. So Vision Systems is the next guy that we have up here. Tell us a little bit about this guy.
Essentially, it's a camera system, typically a CCD style camera, and it's evaluating known. Essentially, we're teaching it what good looks like, and then anything that's a deviation from that, we're using an algorithm or machine learning in order to reject that as well. So mostly used in sorting and grading standards. Where I think it's the most prolific is probably in the nut industry and produce or vegetable sorting in those use cases. Not as much in the manufacturing processes overall, but a little upstream.
Yeah, no, that makes sense, and that's where I've seen it as well. And that's kind of what Duncan is referring to as well. Is these systems are far superior to human intervention, right? We there's no way once you see these peanut sorting machines that remove the burnt, peanuts after roasting and things like this, or on the raw side, screening them out at the beginning for stones and all these other those machines fly, absolutely fly. And watching them is it's hypnotizing, because they'll have these little bursts of air that will poof, it'll blow those little particles off, and you're just like, holy crap. You could sit there and watch that all day long. So for foreign material inspection, this sounds then like this is more of an upfront process than finished product, right? I don't think I've ever seen it for finished product, right, unless you're using it for some type of, do people use this for packaging checks or things like this to make sure the products are in the right package maybe?
So I've seen that as well. In fact, that was the first time that I saw it in the food industry was, as we would change over rolls of film stock, those types of things, ensuring that it matched the batch that we were producing, from a production system or SAP system, that it didn't see a SKU or barcode that didn't match what says we were making at the time in order to prevent error.
Right. So, and it sounds like as well, this is then limited to obviously visual defects. It's not going to pick anything else up other than that. And to your point, it has to be trained, which gets back into some of the issues with X-rays and learning across industries as well. So I would imagine the information they get here is probably pretty closely held as too, right?
There's a company that makes a very fantastic version that I've seen that's used most prolifically in the Apple industry that can do color grading, because there is a spectral aspect of this, at least from a color gradient standpoint, and that it sorts and grades apples as it does this evaluation as well.
Very cool. Let's see here. So now we're getting into some really crazy stuff. So hyperspectral, what in the world is this, Kai?
Yeah, so very similar, but we're adding layers of infrared or near infrared spectroscopy into the same type of systems. Where we talked about nut sorting and things like that, just based on a color analysis, this can actually look at something and say, hey, that's a foreign object. So not only is this a broken piece of shell, but it's not supposed to be here. This could be a piece of bark. It could be a piece of plastic, a piece, of an insect, whatever it might be on the base level from a sorting standpoint. But now I've even seen these in, poultry and meat handling, especially at the primal cut level, before it goes into the next level from a processing standpoint. It's ensuring that everything has been removed before it goes into further processing. And then obviously can do some fat analysis as well because of the NIR aspect of things. So can improve clean and grind operations, or this data can go into, I've seen it, feed cutting operations from a chicken breast perspective to make sure things are sized and cut properly based on width, thickness, protein, fat analysis. So we're still learning a lot about hyperspectral and its applications. And I've seen some integrators that are just basically slapping a hyperspectral camera onto a system and then calling it good. And then, obviously, with like any other piece of equipment, I guess I'll back up first to make this statement. Ensuring that we understand the expectations as a buyer, as a manufacturer, putting clear FAT expectations into our purchase orders is only going to improve our own use case of these tools. So sometimes I do see we lean on suppliers for these, but we do need to make sure that we're working from quality operations, engineering, continuous improvement, and that everybody's getting the right expectations out of the device before we put it in line.
So that we're all on the same page. What does FAT stand for?
Factory acceptance testing.
Yep. So in other words, right, so there's really, depending on the equipment, there's also an SAT, a site acceptance test. So if you're buying a very expensive piece of equipment, a lot of times you'll send your technical people to the manufacturer to check out that equipment before it even gets to your plant. But once it gets to your plant and it's set up, you need to have criteria in place with your factory acceptance test to make sure that it's running correctly. And that company doesn't get paid until it's set up and you're satisfied. Because one of these golden rules in food safety, well, frankly, all of life, is people are much more motivated to go along with what you're asking them to do before they get paid. Once you paid the manufacturer of this equipment and you install the equipment, trying to get things fixed or changed after the fact can be an expensive lesson.
Absolutely.
So with hyperspectral, does this have any speed limitations? Like does it run as fast as a metal detector or an X-ray machine, or is it slower?
I haven't seen any issues from a speed standpoint with the applications I've observed to date. So everything is still running at production speeds.
So you'd mentioned a couple of different industries. So meat, poultry are used. What other type of industries have you seen using this?
The onion sorting industry and grading and looking at onions, and it's basically taking this level of technology, and they're able to determine split core versus single core, bruises, holes, mold, those types of things as the onions are traveling down the conveyor belt for further sorting.
Wow, that's cool. So with this technology then, Kai, is this kind of like you have an object like that onion you were talking about? Is this kind of looking at the outside, or does it have the ability to look a little more inside of the object itself?
Full depth penetration is very limited depending upon the product, but it does have a slight penetration aspect to it.
Very interesting. And price-wise, how does this type of technology compare with the other more standard technologies for foreign material detection?
This is kind of why I sidebarred the right manufacturer. So I've seen some people just take a hyperspectral camera and put it in a system and then call it a day. And those installations were fairly inexpensive. But the better integrators that I've seen, are leveraging cloud-based technology, improving the algorithms over time, and really are working with the manufacturer continuously to make the best inspection technology possible. And those are expensive installations, I'll say the least. Yeah.
So, I mean, generally, if you put a metal detector on the line, once you have the conveyor belts and everything else, you're probably talking around, depending on the system, 30 to 50,000 on the high side. Is this like double that or more, or any? I'm just kind of curious from a ballpark standpoint, how much more?
Yeah, I always kind of just $50,000 for a metal detector, $100,000 from an X-ray standpoint, 200 plus for a good, what I would consider a good hyperspectral setup.
So it sounds like then if you're thinking this technology may be a good application for your plan, so you need to have a good plan in place with your leadership team around ROI and figuring out the rate of return on this equipment versus standardized processes. Because if this new process is saving you money and it's improving food safety, it may be the best thing to go with.
Right. And again, one camera on one conveyor belt, it's very limited from a use standpoint. The integrator that I saw that had what I would consider the best at the moment, there were 8 different cameras over this section of the conveyor belt. And then they turned the onions 90 degrees onto another one so they weren't tumbling and rolling when they went through the first level of hyperspectral, and did another analysis of that. So it's a significant amount of hardware and computing power going on.
Well, and then too, you have this high level of technology in the manufacturing environment. So if you're in a plant that's dirty and dusty and humid, your equipment may be taking a beating in that environment as well. So how are you actually protecting that equipment too to make sure it doesn't get compromised?
Yeah, I was able to go to the company that's building those, integrating all the hardware together before it goes to the manufacturer. And, they have positive pressure chambers where the spectral camera lives so that nothing can get inside of those chambers. And the level of detail to the quality and maintaining the piece of equipment I thought was significant.
Wow. Yeah. And as Cortland's saying is here is like the hardware is nice, but it's really the software that's doing the job. So making sure that that's validated and then verifying it's doing what you want to do is a big, big project. So this may be cool technology, but you also have to look at the effort involved and then the output of managing it and maintaining it as well. So good things to think about there. So microwave, what do we got here?
Yeah, so I mentioned it a little bit earlier, so I won't go into too much detail. In fact, it tends to be a little bit of a black box. I haven't learned everything that I can about microwave yet. But the product, let's take white mass from a yogurt perspective, something that's very homogeneous. It's built to a pretty tight specification with some variation around fat or protein levels. And for each one of those white mass backgrounds, you would have a baseline microwave signal as the white mass passed through the microwave portion of that piping or fluid system. If anything else were to cross that field that disturbed it and represented a signal that was different from the base signal that that product had via microwave, then it would kick off and divert some product flow. Oh. But again, product does the more homogeneous the product, the more effective, and the tighter bandwidth of nutritional, fat, protein, moisture that something is being produced in, the better the use case is for this. But detection, it can detect a lot of things effectively if those two criteria are met.
So Duncan was mentioning earlier, and I'm sure this is something that comes up quite a bit on microwave technology, is this cooking the product?
Technically it is, but not at the flow rate or the amount of microwaves. It's really similar from an X-ray standpoint. Are we irradiating any product via an X-ray system? And no, the power and magnitude that we're exposing product to with any of the detection equipment is not altering the state of the food product.
Okay, so with this, and you have this pictured as a pipe where the product is flowing through. So this is more of a three-dimensional aspect associated with this material versus the previous technologies is kind of what I'm getting out of this.
Right. I think that's why it provides such a significant improvement from a detection standpoint.
Mm-hmm. So what other type of applications are you seeing out in the field where people are using this technology for foreign material?
Some jams and jellies before inclusions are added to it. Again, I mentioned white mass from a yogurt perspective. Any opportunity where there's fluid dynamics at play, and we have very little variability in the amount of sugar or fat content. If we have a wide range of variation, then this isn't the best technology.
Not going to work too well, huh? Huh. Interesting. Okay. CT. What's CT?
So computed tomography, again, this is taking X-ray from the 2D world to the 3D world. And we're taking a gantry and running around the product continuously and rebuilding that. Same thing from a slice standpoint that we talked about earlier on an inline perspective, but we're taking, X, Y, and Z axis of slices now and rebuilding all of that into an entire three-dimensional model of the product.
Wow.
Now, essentially, detection rejection still occurs on the basis of what's going on with an individual slice or adjacent slices, depending upon how robust your computational power is and how developed your algorithm is. And we can look at adjacent slices at the same time for determination as well.
Yep. And so for your fourth bullet point, there's speed. So it sounds like this has got to go pretty slow because it's got to have enough time to rotate around and get that whole picture, right?
Yeah, we're creating a lot of imaging here. We're making an analysis on a lot of different things at the same time. Now, obviously, as computing continues to improve, the speed of this equipment from a manufacturing standpoint will continue to improve as well. But right now, 30 feet per minute if we're just targeting metals only and we're not looking for glass or ceramic or plastics, those types of things. And then from a FlexRay perspective, we're commercializing this technology. Right now, we have a gantry in play at one of our facilities, and we're looking to add more of this starting in January of next year.
Gotcha. So this sounds more like more of an in-depth offline technology. I don't think anybody would be using this inline for managing foreign material.
Yeah, there's a few players in the European market that are using this inline. One example, a gluten-free bread manufacturer, where the size of the holes or voids in the bread tends to be a source of, pain and suffering for a purchaser. And they've used this in order to not only evaluate that from a defect standpoint, but help improve the root cause of those voids upstream as it relates to potential yeast issue or cooling issue, whatever it might have been that led to that.
Interesting.
Keep the process in play.
Yeah, I worked in gluten-free bakery for a while, running it for a company, and yeah, I from personal painful experience. Yeah, if you have opening and voids in the bread, that ticks people off, right? You can understand why, right? You want to put jelly and butter on your bread, and that doesn't work quite as well as it should. So oh my goodness, time is flying. We got about 5 minutes left here, Kai. So let's kind of wrap this up at the 30,000 foot level. So for these different type of activities, what considerations should people have for the different technologies here?
So this is from an inline X-ray perspective. We'll just kind of take the rundown as if I'm buying a new piece of equipment for my plant. What does my existing product look like? No foreign material, nothing else. Like, what does my image look like right now with that piece of equipment? And really that baseline is going to be the foundation for exploring what I can expect to find later. And then of course, targeted foreign material is subject to whatever is in your manufacturing process overall. And some of the things that I think that are worthwhile, we talked about aluminum earlier. If we're going to rely on X-ray only, we want to eliminate aluminum as much as possible because detection is very limited. But then O-rings, gaskets, things like that, if the cost of our product and the cost of throwing it away is to be avoided as much as possible, and hopefully it is, and we're making good decisions about hold release, we really need to be making good decisions about the usage of UHMW or HDPE plastics. And let's move into better pieces of plastic that are going to last longer, that are going to be easier to detect, that are better overall. And that nickel gasket is going to cost us significantly more than that in the long run.
Pay me now, pay me later.
Exactly.
So X-ray, real quickly here, what do we got? What's your final thoughts around X-ray?
So again, this is just KV imaging devices, things like that. Just trying to understand that the best detection technology, the smallest pixel size, the smallest piece of foreign material that somebody can pick up, that doesn't necessarily mean it's the best piece of equipment for you. The diversity of your product, the signal to noise that it might create, it may create its own set of problems. So understanding those types of things is very important.
Very good. Cool.
And then just an example of CT scanning capabilities. So this is an extruded chicken product from our inspection. In the bottom right, there's a 3.5 millimeter piece of Teflon gasket, and there's a 2 millimeter piece in the top center.
Gotcha. Well, there you go with that. So obviously, Kai, thank you. I mean, a ton, and definitely we're just scratching the surface here for sure. So we'd mentioned earlier, so you guys are going to be out at the IAFP, correct?
Correct. We'll be out there next week. Come by the booth, say hello.
Definitely. And do you guys have any events coming up or anything else you want to let people know about?
I think there's a happy hour during the week as well, but I do not remember the date. I don't have the itinerary in front of me. But we're at pretty much all the food safety trade shows we're now in attendance with, and with the CT technology, we'll probably try to help. That the manufacturer of that is an Italian company, and we'd like to help them demonstrate that piece of technology probably at the PAC Expo in the next year.
Nice.
A little too late to get in this year.
Well, and part of this, again, this goes back to something that we talked about on the chat here quite a bit, Kai, and this is kind of a good way to kind of wrap up our talk here today, is, guys, remember, you don't have to become an expert in all of these different detection technologies, but you have to have a baseline level of information so you can have the conversation. You need to be able to determine what are the criteria for your product. Every product is different and they have their own challenges. So for example, if you're making a granola bar, holy moly, you got challenges because you have all these different densities and gradients and different types of particles that are all jammed together to make this bar. Really hard to detect things. So if that's the case, you need to talk with experts to figure out what is the right technology for you, how is that implemented, and how do you then integrate this into your processes in a way that you can continue to manage over time. And the important piece as well is if you have an issue, you need to have the experts available to you that you can talk with to work through these type of issues. People like FlexRay and Kai over there, being able to pick up the phone and talk with those experts in your network is super, super important. And thank you, Mike, for putting in the information here. Greatly appreciated. So if people have additional questions, Kai, how can they reach you?
Just calling FlexRay is probably the best way, but I would say I'm more than happy if you're trying to go through an FAT or a purchase of a new piece of detection equipment. I'm more than happy to help you try to build that that case study that you need. You know, instead of having somebody just trying to sell you the best, most expensive piece of equipment they sell in their portfolio, let's find the thing that's best for your use case.
Nice. Yeah, because salespeople may not have your best interest at heart. So one of the things with the locals group that we have here as well, and I put the address in there for that, it's free, is I post in there a lot on foreign material recalls. And this is a good database to build up because this is information you can bring to your boss to say, hey guys, here's what's going on in the industry out there. We need to protect ourselves and up our game for foreign material detection. And there's all kinds of different options out there that we can look at now. So, wow, fantastic chat, Kai. Thank you.
Bryan, thank you very much. Appreciate being on today.
Oh, you bet. So, guys, we're going to close out our chat. And thank you, everyone, for the fantastic comments and feedback. We really love it. We really appreciate it. And we'll bring our chat to a close here for this week. And don't forget, we'll be back here next week at the same time. So 8 a.m. Mountain Time, 10 a.m. Eastern on LinkedIn, YouTube, and Twitter, where I bring another amazing guest on the show like Kai. So in the meantime, please enjoy your weekend. Have a great time. Stay out of the heat. If you're in a hot area, stay cool, but have a great time. And we'll do it all again next week. So thanks, everybody, and enjoy. Thanks, Kai.